Hello, hello. And we're back. And we are going to work on Kast. Hello, Penguin Operator. Do. Alright, what are we going to work on today? Is hopefully we can start working on the actual like ability to write proper, I don't know what do we call it, like derive macros, or like, I mean, yeah, in general, the metaprogramming, the way I see it. Hopefully we get to see that today. So we already have the macros. We have macros which are hygienic. The macros that are hygienic are done in a way that it's not only about introducing the new symbols, but it's also about accessing the symbols. So we can like do stuff, which is pretty cool. The missing part is the ability to inspect the types at compile time, right? So when I want to derive the JSON parser for a custom type, right? We need to be able to basically say in the code, we want to be able to say in the code something like this. You know, I don't know. We want to be able to say like derive trait for my type, right? Or whatever, right? And how how would that work? I mean, I think this maybe not even needs a dedicated syntax, right? Hello, Nerdsoul and Devninia. I think this shouldn't even need the dedicated syntax, but maybe it's just a function that is called, you know, derive my trait, and we call it with my type, but we call it at compile time, right? Something like this.
Hello,
Or maybe we have the syntax sugar for it. We have the ability to add custom syntax sugar as we please. So yeah, that's like the idea. So this this is going to basically call the function, you know, call the function derive my trait. This is just like a function from type, and this should return some AST, right? And whatever, like, we basically, before we can generate the code that does the deriving, we need to basically get fields of type or whatever, right? So this part is what we are interested in, right? So we want to be able to like investigate the types, right? Format request failed. Of course, it's NeoVim complaining about the thing again. Oh, I know why. Yeah, no, that makes sense actually. Forget about it. Yeah, I was like updating my system. I think I got rid of the cursor bug. You want to guess with which language I'm currently working? Which one? Kast? Are you trying to write something in Kast? Or are you trying to tell me about Erlang again? Or Camel for .NET? The F sharp, you mean? Do you like it? F? Hello, Vincent Weissen Dillinkar. That's not the first time I see your name, but I always struggle to read it for some reason. Alright, let's open the... You still dislike the module system? Well, there are things to like and not like there, for sure. Only Clonk can read it? Oh, you mean your name? Okay. Yeah. If Rust would have had the module system of TypeScript instead of their garbage, I would actually love it. Wait, what? Rust's module system is pretty good. What's wrong with it? It's, how is TypeScript's one better? File system-based module systems give me the ick. Isn't that what TypeScript is? Because you can only have a single module in a single file, but Rust actually gives you more flexibility. Unless you can, and I'm not aware of the method. TypeScript, multiple modules in single file. Is that even possible? Well, I mean, a module is just an object. So, like, yeah. I guess you can just create an object. But otherwise, it's like the same. You can think of it as a special, as a syntax sugar. Spreading namespace across multiple files is a no-no for me. But it's not spread. That's not how Rust's module system works. I'm not sure what you're complaining about here. Spreading namespace across multiple files is a thing. Maybe in F sharp. I didn't try F sharp myself, but that's how you do it in C sharp. So probably that's what you do in F sharp. That's not what you do in Rust, though. You said you were complaining about Rust, not F sharp there. Unless that was a typo, you were complaining about F sharp actually. I think you meant F sharp and not Rust there in that other message, right? Both? Well, the module systems are completely different in F# and Rust. TypeScript is better than Rust and F#. Well, that's an opinion, I guess, that I definitely don't agree with. Well, I mean, I kind of agree, but at the same time, I don't see why do you like how is TypeScript different from Rust? Like it's literally like almost the same. The only difference is that in TypeScript you treat your modules as objects, while in Rust you don't. It's F# that is completely different. Rust is just like having more, I guess, syntax sugar than TypeScript for the modules. That's like the only difference, I think. In Rust, my file name has to be the same name as my module? No, it doesn't. That's not true. That is not true. That is so by default, though. Which I think is a default that makes a lot of sense, though. Why would you want to name your file something different? I do name them different sometimes. For example, when your module has a different implementation based on the target, like based on the target, right? If I'm compiling for the WebAssembly, I want to load the module from one file, and when I'm compiling for the native, then I load it from another file. That's what I do, yeah. You can change it. But like 99% of the time, you don't want it to be changed, right? You can, though. Yeah. You didn't win conditional compilation. Well, it's the behavior is that you can just say from which file the module needs to be loaded. So it's basically like splitting the name of the module from the name of the file, which could be combined with the conditional compilation because it's done through the attribute, and the attribute could be conditional. That's how you do, right? But like, why would you do that? Comptime reflection sounds like something one would do while waiting for cargo build to finish. Yeah. Hello, Happy Nora. All right, yeah, let's get started. I think what I need to do is I just literally need to give the APIs in the form of the native interpreter things, right? So this is comp time reflection, not exactly compile time reflection, because it's a runtime reflection, but runtime that's happening during compilation. So this is what it means, comp time, right? But essentially, it's going to be happening at compile time. But yeah, it's going to be implemented in the interpreter. So we have this idea called the derive, and we want to turn this idea into the actual thing. Boom, 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 boom. Let's move this into the actual example here. All right, there we go. So we have no native reflection get info, and that's what we need to do. Let's just take a look at this file because I don't remember when I was writing this. What if you run your program at compilation time of the macro evaluation, then when running Kast scripting language instead of an in-game editor at runtime? Yeah, I guess you should be able to do that too. What would you call that then? And, well, I mean, since it is going to be done in the interpreter, when we are targeting the interpreter, we should be able to just query the type information at literally runtime, right? It's just this stuff would not be implemented in the JavaScript backend. All right, so we have reflection. So this is a module that's supposed to go into the standard library so that we can get the information from the type, right? So if we have the type, we want to get the type info. So this is another struct which gives us what actually is the type, right? I think that makes sense. So we can like pattern match and do all of this stuff. And I guess one of the things should be like unknown. So that we potentially... So like basically everything that is not implemented would be unknown. Or should it be just panicking at runtime if I try to get the type info of something that was not implemented yet? Those would be two different things. I don't know. Let's start with panicking maybe. So let's say that I want to be able to get the type info, and this would only give me the int. $32. So basically this over here should literally be the same as the definition of the type in my in the language, right? Ideally, I guess in the future, when the cast is written in itself, this would literally be the same type, maybe, that we use to compile cast itself, right? Is that how it's done in Zig, actually? Or is there two separate things? I don't know. It makes sense to like just expose the compile internal. It just must be in sync. So let's just say that. Oh, here's my types, right? Here's my types. There you go. These are all the things that we have. And I want all of them to be a potential variant. Right? And what is the associated data with it, though? That now depends. So would I also... Would I inline this here, or would I not inline this here? I'm not sure. Type... Also, I'm wondering how would I want to structure this. I think I would like to just say type info.ref, and then so we will have type info as a namespace, basically, as module is going to be the thing which has the ref, and this is the type, which is the this type ref, right? So this would be, you know, mutable. And referenced is another type. Actually, here's the question. Should I, when we have the nested type, should I give you the type info, or should I give you the type, right? Because we we should be able to just get the type info if we have the type, right? Yeah, we should just be able to have the type info if we have the type. The type is potentially also... Oh, wait, yeah. Because the type is potentially not inferred yet, but this thing is the inferred type, I guess. Yes. So I call this the type shape. It's the inferred type, and then the actual type is the inference variable, which is inferred to a type shape. So I guess we just do literally the same thing. Should I call it the type info or type shape then? I don't know. Type info makes sense. So should I, when I will rewrite it, the cast in itself, I don't call them shapes, I call them infos, type info. I don't know. It's basically the inferred type versus potentially not inferred type. What do other languages call these things usually? Error doesn't have fields. Of course, it doesn't. What, why not? Why not, though? Alright, let's comment this out, because this is not going to work yet. Let's just have the definition, right? This is me trying to derive default value for type T, right? In this case, we don't really like derive the trait, but we just have a function that constructs the the value of the given type. But we do need the reflection for that too. Let's comment this out and see what's wrong. Cast examples derive. Type derive reflection dot type info doesn't have fields. So here's the thing. I guess what happens here. What happens here is that I resolve this to this, but then the implementation of this as module happens later, so that we cannot access this field. I feel like this should be how I want to structure it in the future. I can work around it for now, but I think it just means that everything... Does mean that everything should potentially like already have a mod, like a thing. Classic F# issue. Well, I mean, not really. No, that's a different thing. You don't treat types as modules in F# or in OCaml, right? Or do you? Maybe you do. Do you? Like in C#, you do have like static methods to classes, right? Static members of classes. That's basically what it is. This is static methods, static things associated with a type, I guess. This should work. Also, another limitation of this right now, one of the things is that it's just ugly, right? For now. Ideally, we just try to, like in Rust, impl type info here, and that's like all, right? So this basically drops me into the namespace associated with the type, and I should be able to do it multiple times, and right now I can only do it once. So I think the way it works is that everything, like, it should have the associated, like, namespace always. And this just drops me into it so that I can extend it. You know, I'm not going to work on it right now, though. Let's work on the actual reflection. So we are just going to flatten this. Right? I'm just going to say type info underscore ref instead of a dot ref, I guess. That should work. Okay, and then we just get the info. Let's do this. Let's do this. And let's just do something like this. dbg print reflection get info. And we will try to get the info for the int32. Right? So this should work as soon as we implement it. Let's implement it. So that's going to be in the natives. And in the natives, I will want to have a new module called reflection. In it. This just give me the list of things, right? Yeah. Let's see. So what we want is we want to have a native function called reflection dot get type info. Should it be get info or type info? I think it should be type info, right? Should this even be a function? Or should it be a generic? I mean, in this case, it doesn't really matter, I suppose. Depends if you want to support runtime reflection or not. But my generics are also able to work at runtime, so it doesn't matter. That's not the real thing. It doesn't matter though which one, like, because basically my generics are regular functions, right? If you forgot about that. So I guess, yeah, there's the only one of the only things is that they are supposed to be inferred, but there is no way you infer this thing unless you're specifying the argument explicitly anyway, which means that it is always just the function, so with like a different with just a different syntax in this case. So I guess it doesn't really matter which one is it. We're just going to have a function type info. So the argument, we have an argument. Argument must be a type. So this must be a type. So if it's none, then we say error. Needs type as arg. got this. So if we have a type, then we say type well here's the another funny thing, right? Why am I doing it a type reflection if we can reflect on values too? And even today I got older. Is it your birthday? Happy birthday. What are you going to do on your birthday? What did I do on my birthday? Did I stream? I don't remember. Maybe. So yeah, like, doesn't... Why wouldn't Zig... Why would we not need the same thing but for values? I don't know. Let's start with types. So we say type await inferred, right? In order to get the information, it must be inferred. And then we just need to construct this thing based on the shape. So we're going to have this big match, and we're going to construct a value with this thing. With this variant type, right? So, but how do I construct this? Because in order to construct a value, which is a variant type, I need to know the type of the variant type. But we do know the type. We have it over here. This is the type of the function. This is the type of the function reflection type info. We get it from the from this type annotation over here. We say type into type info, right? So we know what this type is because it's over here. So type info type, right, is the function result. But this should be, of course, inferred for us to be able to do something with it. And it also must be a variant, because that's what we define it as here, right? Which means that we are going to say option unwrap here. That's okay. Unless you're writing your own custom standard library, I guess. So this is a type variant. Type variant is a thing which has variance, which is a row, a variance, and a name. Wait, if this is a row, how do I get like the one? I think that's what Nigel already did before in the module net. How do we find the variant? Should probably make this into like a function. Expect variant. No. Maybe I can just see where expect variant is used. But it's not used here anymore. Isn't there something that returns... oh, wait, maybe it's in a string. Maybe? Is there something that returns an option? Nah, this one is implemented in the language itself, so that doesn't... Wait, it's a tuple. Right, in the net, maybe. Expects tuple. Net over here, expect tuple. The structure input argument as expected type. No. I think that's the other thing. Where was it? Basically, we define our type in Kast itself, and we want to get access to the type that we're trying to construct the value of in the interpreter. Pretty sure it was in the networking. Guess not. String method contains? No. Sys? Oh, maybe it's sys? Let's take a look at the sys module. Maybe it's because we returned the option here. Oh, it's okay. It's because Nigel did not do the expect variant. Maybe I did not have it at the time. Yeah, we just do it manually here. So yeah, over here, right? SysgetEnv is the function that is supposed to return option, right? So we basically assert here that the result type of the function is a variant type, and this is the variant type that we have. And we want to construct the label, the variant called none here. Option T should have first variant sum. Oh, wait, really? Yeah, I think this... So, like, this depends on the order of the variant construction. It could be done better than this. Maybe let's just write it and have a function, reuse that function over there too. What I want is to be able to basically construct a variant of a... So type is going to be variant type, right? Data is going to be an optional value, and the variant is... So the variant we're going to give in the form of a string, so that we can look up the variant in this type. So this is supposed to return us, give us the value, I guess. Do I need to have the type variant here, or did I just give it the type? This can also return, like, types value variant, I suppose. Let's start with that, actually. Sure. So value variant has a label. We need to find the label. We need to find data, and the type. The type is already correct. So the data is supposed to be an optional place, right? Because we need to create a new place with the value, right? Mutability is going to be inherit, I guess. So this is data map, like that. So now we only need to find the label. Label is not a string, it's a label. So we want to actually find it here. Hello, Boruchak. So the label is going to be found in the type itself, right? So we say type variance. So variance, this is a row. This is a row, right? So I think that my row should just have the thing called like find await inferred to list. Oh wait, hold on, we can await inferred to list. Is that a thing? So this would give me the list of label and values. But we don't want to await inferred to list. I actually just want to be able to find right? We will call it await find because we will need to wait for the inference for that to happen. Await find find opt, I guess. So we are going to find the label. Wait, but label is label. It's not a string. It's a label. So we we potentially can have multiple labels in the row with with the same name but different label, because they can come from, I don't know, different macros or whatever. Because of hygiene, this like as a string the symbol can be the same, but it's going to be different. No, I'm pretty sure that's not the case. Because that's a label, that's not a symbol. Let's call this label string. Label value rest. So basically we say that if label, if string is equal label label name and label string, in this case we just return some value, otherwise we need to do it recursively in the rest of the row, right? One thing I'm not sure about that I like about like the row types is that looking up is linear instead of like just looking up in a map, in a hash map. Not sure if that can lead to any actual problems. Like if we actually did not use the row polymorphism, but we did like the normal thing, like for tuples. then that would be instant. All right, anyway, so we await find opt. So we're going to wait find opt to the variant, I guess. And this is my variant type, I guess. And we say label is variant type. So this should be what? Also unwrapped. Option. Unwrap, or else let's have the span here too, I guess, so that I can report the error here. And in this case, we will return the error. Right, so we're going to actually match this. With none, and we return. Oh, but yeah, and that's why we cannot return the value variant. We must return just value. Type variant data does not have the label. Wait, I need to find both like both the label here, right? Yeah. So this should return some label and value in this case then. So in this case, yeah, we find label and data type, I guess. But the data type, I guess, type variant data. So this is an option which must match the value, so we can check for it. I guess. Right, so we can say that if maybe we can like match data and data type. If it's none and none, then we don't do anything. If it is some data and some data type, then we kind of just need the type of data. Should be inferred as the data type. And if we have like none and some, we say that type variant expected data got no data, and in this case it's the other way around. Variant expected no data got some. Okay, yeah, that's... Oh wait, this is type args? Wait, but type args is just type, right? Okay. So now we should just be able to use this to construct the correct thing, right? So if we have the type which is a unit, we should construct the variant. We should construct the variant of the type info type variant called unit with the value being none, right? So there is no associated data there. So that's like in general how we just do this. Right, so in this case it's going to be a boolean. In this case it's an int32, int64, load 64, string. Let's go through these simple types first. Char, and in the other cases, let's just save file with lock, I suppose. A value shape native reflection type info is not native reflection type info. Wait, what? What do you mean it's not equal? Native functions are never unified, which is wrong. We have a to-do here. Is that a single to-do in this file? So if it's a native function, it just has ID, right? And I just need to figure out that the ID is the same. So when AID is are equal, in this case, we just return a native function A. Is it exclamation mark equal, slash equal, equal slash equal, less than, more than, exclamation equal, or dot dot dot? Which it is not equal, are we on? In my language, I am using the first one, the exclamation mark equal. I feel like that's what most people are used to. Are we like... I think that's right, yeah. Yeah. I feel like even in the functional programming world, people are using different symbols. Right? So it's not like... It was just a fun if you say not equal in voice, which operator are referring to. Yeah, but like it's actually like a valid thing to think about, right? What do you do in your language? Or do you do you have multiple equality operators with different semantics, like JavaScript, I guess? I mean, I have the not equal as a ligature here, right? I don't have this ligature. So I have the ligature for exclamation mark equal, but I don't have the ligature for equal slash equal. Oh, wait, I do. No, wait, I do. Oh, What about equal this one? This one is also there. This is the triple equal sign. What about slash equal? Slash equal is a different ligature, so I think we would not use that because of that. Because that's like the, I don't know, like it's kind of like a standard of how you do these ligatures in fonts, I suppose, maybe. I don't know if it's actually like, if there's actually any standard. Less than or equal. That becomes like a diamond thing. See the habit of slash equal? We are so used to typing slash equal. Who we? Who is we? You used to use switch to this because it's faster to type. Wouldn't mind. Or you're talking to yourself as we? Okay. The mind and body of the borough checker, yeah. Two separate things. Yeah, I think like slash equal, like I feel like font ligature thing is a good enough reason for me to not use this, basically, right? So the only option that I see is the first two, which is, so the first one is just exclamation mark, and the second one is equal slash equal, right? So those are the only options that I would consider. Just because of this. Haskell, Ada, and many other languages use slash equal. Yeah. I mean, maybe there are fonts with different way to like do this ligature. Maybe this is not standard. I don't know. Maybe Raymarch knows all about ligatures. We're thinking about what should be the actual like operator for the not equal. Another option, by the way, is to not have the operator not equal at all. What if we only have the equality operator and we just say, you know, like not A is equal to B? You know, that's another option. How do you say not in your language? That's another question. Do you use the keyword not, or do you use the exclamation mark? Because if you use the exclamation mark, then exclamation mark equal makes a lot of sense, actually, right? That's the negation. Or I guess since if we do that, then you could select not equal as an operator. The one as shown, that's how math does it. Yeah, but like we still want to not use the actual Unicode symbols in the code. I mean, I am not at that point yet where where I'm okay with doing the actual Unicode. Ligatures are fine, but Unicode, random symbols, I don't know about that. Using slash for division is a mistake. What should we use? The colon sign? Or do we like write code in two different lines? Do we just say, you know, like, do we say like A, B, like this? Plus C? Is that how you want to write code? We almost forgot, why is division colon in written maths? I don't know, there's like 10 ways to do the division in math, no? Vertical align arrangement and a new editing paradigm. Well, I mean, you can, like, if you just embrace the visual programming, then I guess that makes sense to do. But I don't think I am at that point where we want to do the visual programming. And yeah, not at the Unicode, not at the visual programming point yet. Not yet. Which is why slash makes sense to me, you know? Because like, it's like, how do you do the vertical thing, but horizontally? Well, you just like rotate it a little bit, but not like fully, you know? What's the font I'm using? I'm using the monospace. I think I have the command even. There we go. Make times x again. Oh wait, error. What do you mean error? What do you mean error? It's not an error. Huh? What do you mean error? In this case, v error, right? Because we did not find the variant. Is that what happened here, right? I should probably like report the error here too, right? Did not find variant this, right? Because that's what's happened, right? Did not find variant int 32. Oh, because there's t int 32. I think like I only did t because it's a camel. But in Kast it should be less annoying, so we could just name the things without weird prefixes. There we go. Does it mean that I already have compile time reflection? We just need to like fix all of the missing gaps here. And then we just use that to generate some code. If a caret b, caret is not equal. In GLSL, wait, what? GLSL not equal. Operators. There's no way. Let's just Turner operator. Sequence. Logical exclusive OR. No, it's a logical exclusive OR. Or is logical exclusive OR is the not equal? Is that what you mean? Yes, it's either this or that. Well, it's only like it's only for the booleans. No. I guess that it is the not equal. Yeah. I think I have actually used something. No, probably not. Like I did something with the booleans where like instead of the logical operator, just use the equality or not equality. Maybe I actually did that, but I just so I wanted the logical exclusive or, but I just said not equal. GLSL has the implementation defined the negative reminder, negative bullshit reminder. What? Where? There's no reminder in the logical operations, right? Unless you are talking about the remainders. Literally the remainder operator. I think if I remember correctly, the remainder operator, the modulus, as you can see, not implemented because it was not implemented. Like you cannot use the modulus operator basically in the original WebGL 1. I remember having a function for that instead. Did they actually specify this later? I mean, you just have the mod function, right? Compute the value, module another. This is computed as x minus y times floor. So like this is pretty well defined, right? The module is always like it is the modular operator, right? So it always is. Wait, is this always positive? If y is negative is the question, I guess. What's going to happen? I don't know. But yeah, maybe this is different from the operator, actually. It makes sense for the percent to be the divided by 100. Everything else doesn't make sense. Yeah. All right, let's move forward towards this thing. So we want to implement this simple trait using a derive macro-like thing, right? So we are going to say this, that default value of type, right? So we are matching this thing, and if it's an integer, then it is 0, right? So this is not implemented yet, but we can do this. Right? We can do that. No, we need a module because I want this to be recursive, I guess, right? I need a simpler way to define recursive functions. So, foo. Let's just say this is foo, and let's just do dbg print default value, which is an integer, right? So this theoretically should work now, because it is implemented for integer here. It did not work. Oh, because it's not a function, of course. Of course. Of course. I guess we just do... yeah, if it's not a function. This is like a generic constant. So we just do it like that. Wait, no, it's not. Wait, yes, it is. Wait, what? Default value. T type. T type. This is unnecessary. There we go. Okay. Default value. Yes, the thing is that this should return. Yeah, because this value has the type T. Is the idea, right? And I cannot specify that thing here, really. Unless I surround this with parentheses and say T. Or I can say also T, like this, maybe? No? Fine, let's run this with parentheses. This should work. But this now says that number literal is T. Yeah, I cannot do that. Wait, what? How do I do this? So like, I'm trying to compile this function. Let's just say default value is going to be like, you know, just say that it's a function that returns t after all, right? Because that makes more sense a little bit. Probably. So we just do this. And in this case, we just say that this is a function that I'm supposed to call. First calls is Rambu Euclid instead of modular. Yeah. Not sure if that's a better name though. Is it? So here's the issue, right? We have a function which is a generic function. This is a generic function body, but the return type depends on the argument. Basically, it's kind of like a dependent function. That's what the generics are, right? So, yeah, we basically inside of this we just know that this should return t, which means that 0 here must be of type t, but t is a generic type. So, like, what does this mean? Number literal being a t. We don't know that, right? How do we figure that out? Because, like, the way it works in Zig is that you don't type check this function before you run it, basically. So you only type check at runtime. Should I also have a way to type check at runtime? Or another way that we can do it, the way that basically we do it is we delay the type checking until runtime. But how do we do this? We do this by instead generating code in the form of the AST and compiling it later, right? So we make it a macro instead, which basically, yeah. Basically, the functions in Zig are technically not functions, they are macros because they generate the new thing, right? It's like templates in C++. They are not generics. They are type checked only when you instantiate them, which means that, like, how are they different from a macro? They are just macros, right? So we generate code here like this, 0, right? Which means that this should return AST, right? Default value for, like, the type. So this should return AST. So this is going to give me 0 as an AST, right? If I say 0 plus 2, we just have the AST of 0 plus 2. And then we want, but, so yeah, basically we instead implement the trait, right? We have the trait default, which is just a trait, which has the default. It's just a function that returns self, right? That's what we want. And then we want to implement. So yeah, that's why we basically still need it as a derived macro, right? So we just implement we implement int32 as default. As default is 0, right? So that's how we do it here. Then we'll say int 32 as default dot default. So that works. But we want this to be derived instead, right? So we want to say derive. We want to say derive default. Okay. Let's do this. Include AST derive default for int32, right? Derive default for is going to be a function that takes type and returns AST. Right? So we want to basically say we return the AST, which says implement t as default to be default is this returning 0, right? So I think this should just work, right? It will say conflicting implementation though. No, it's I need a semicolon here also. So this works. Wait, I don't check for conflicting implementations, or did it actually not do it? No, it did do it, right? It did do it. So there we go. We will have like better thing than this, but that's basically the derive macro that we have in Kast now, right? We just have the type, and it can generate any AST it wants. But now that we have this type, what does equal mean in Kast? Assigning. I mean, like in Rust, I guess. Yes. Disgusting. Yeah, I know. I know, right? Yeah, we don't do the left arrow. We had this conversation before. Not even left for mutation. I don't like left arrow. I don't know if you were here on the previous conversation about this, but basically if you have like a right arrow B meaning the function, then Y a left arrow B means mutate A, because like the arrow going in the other direction meaning completely different thing makes is making it weird. I think, you know, if we use this for mutation, then this should not be mean a function type, you know. So over here, what is this? In this case, this is going to be the T default AST, I guess. And over here, we basically match on the reflection type info, and this is going to be my my T default AST, I guess. Yep. Yeah, that's what we do, I guess. That's all. All right. What do you think about this, Ray March? If you're paying any attention. The way we do the derived macros here. So first of all, like, we want to support more types here than the integer, of course, right? But yeah, we don't have a separate stage for the derive macro. We have access to the type information in our derive macro, and we just refer to the symbol in our generated AST. This symbol, t, refers to this t, which is the function of this argument, which is actually a constant, which is int32 in this case, right? I think this like shows a lot of like features of the metaprogramming here. So let's say that we have the can you check if t bound? Not yet. Not yet. But I guess you would be able to. Although at the same time, the problem with checking if t is bound is that, so it depends on the order, I guess, if I just do it in the naive way, right? Because the implementation, like deriving the trait, is basically the thing that happens at in the interpreter, which is running at compile time, right? So the trait implementation might be added later, so but it is not available right now, right? So when you do the checking, do you want to wait for all of the bound, like when do you perform the check is the question, I guess, right? So yeah, maybe you should just be able to like look into like certain points. But if you use this for deriving, like let's say that implementing the bound trait for t also is waiting for something else, right? So now you are in this pass. So it's a little weird. I'm pretty sure that Jai just gives you the way to. I mean, first of all, Jai doesn't have traits. Let's start with that, right? So over here, when I'm getting the type information, this is already waiting for this type to be fully inferred, right? So even though I could give this over here the underscore, which means that we don't know what we are deriving the default for, if I try to run this though, this is going to say that you cannot wait for this variable. That's what the error says here, right? It's not inferred and it cannot be waited for. Not sure if Jai does it exactly the same way, but you can wait for inference. Waiting for the implementation to happen. I mean, if you are sure that the implementation is going to be there, right, then you can wait for it, right? So if you know that something will happen at some point, you can wait for it. But if you don't know whether something will happen in the future or not, then like how do you wait for that? How do you wait for whether the thing is going to happen in the future or not? Well, you can wait for it, I guess, because at a certain point, you are not allowed, maybe, to add implementations to the types, right? Because of something similar to the orphan rule in Rust, right? Maybe then you can, because once your current compilation unit finished compiling, you are not allowed to add new traits, or I mean existing traits to existing types anymore. Or something like this. But yeah. How do you do this? Wait, how do you do this in... You can do this in C++ though, right? With some template magic. So how does C++ do this? I guess in C++ you cannot like can you conditionally include a member in a thing? In a class in C++? I don't think you can, right? You either have a member or not. So you don't really like wait for the implementation to be added, because you don't add anything later. In C++, the whole compiler is recursive. I mean, that's the same for me, I guess. I'm just wondering if you have seen the something similar to like that in C++. Like, I mean, why would you want to check if the type here implements the trait or not, right? That would be what? That's like specialization. That's how you do specialization, I guess, right? If you could do that, then that would allow you to do specialization easily. You can do core stuff like that, especially in C++ 26. All right, we need to figure out how to do something similar to that then, right? It's important. C++ has specialization. Yeah. But like, you don't need a dedicated feature for specialization if you can just do this, right? Because you just specialize with an if. That's all that's needed to be done there, right? All right, let's just add more missing things. False in 64 0. String char. Is there such a thing as a default char? Char from code 0, I suppose. Sick in bed, not enough brain cells. You have more brain cells while sick in bed than the self has been healthy and functioning. Yeah. What's hopefully it's nothing serious, Remarch. So if we have a reference, maybe we should derive toString. I think deriving toString makes I like toString more. Derive toString. 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 Self string. Oh, here's the question though. Ooh. So if we have a self here, right? This is a symbol defined in this AST. If I try to use this symbol here, right? Let's just implement this for Boolean. Right? So if self, then true, else false. right? Something like this is what we want. So the question here, like, this is actually not supposed to work because this self and this self come from different ASTs, differently quoted. So the macro hygiene should treat them as different symbols. So we want to derive toString for a boolean, right? And then let's just say let's have a function toString tx t string ts toString x. Right, let's debug print toString true. That's not going to work, right? It could not find default in scope because we want to derive toString here. ToString is yep. Yeah, there we go. Could not find self in scope. Could not find self in scope, this one, right? That makes sense. So how do we make sure that this and this is the same symbol? Well, we can say self, and we can say that self is a separate AST. That's how we like basically generate a symbol. And now we can just inject the symbol here and there. I think this should work, right? And in this case, self should be dereferenced, I guess, because I made it for a reference type. There you go. The true is here. All right. And we can also have the special syntax for deriving. So what I want to write here is literally just derive toString for boolean, or maybe derive boolean as toString, since that's the order that I'm doing it here. So how do we derive? Maybe the way we derive is maybe we have another trait which is called derivable. How about this? Derivable is a trait which is implemented for the trait that we are deriving, right? Like this. If we have a trait, then we can derive the trait. And this is going to say that derive is a function derive is a function that just takes the type and returns the AST, which is the derived this thing. Which means that it's just a type, like I don't even need this, right? So can I just implement toString as derivable? I'm not sure if I can do this if it's not like generic. So derive is derive toString. Cannot cast into derivable. Now, I guess fine. So like, even although I'm not using it here, I suppose. Yeah. In the definition. So then when we actually derive, this should basically be, you know, so derive bool, let's actually make this the proper syntax. Derive, let's see, derive type as trait, right? So we implement syntax derive type as trait. And this is just going to be basically just include AST trait as derivable, derive for type. And then we just derive bool as toString, and then we toString true. No implementation of toString as derivable. ToString as derivable. Wait, is this not it? But this is it, right? You can just not find it. Also, I think that we just implement the derive over here directly without going through a separate function. This is my syntax. Also, I don't need the derive field here, technically, right? Derivable could just be the type into AST like this. So we just take this and call that function directly without having a derive. So just say implement as derivable as this function. Right? We can keep the annotation, I suppose. Same stuff. I just need to figure out why the thing is not there. Function type cannot be expression. Well, yeah, sure. We need to have type. I suppose like this. So the only issue is there is no implementation of derive toString as derive toString. Do we have no implementations like something as derivable? But why not? Implement toString as derivable. There is no such implementation. So where did it go then? Wait, is it because I'm trying to do this at compile time, but the implementation was added at runtime? Is my implementation added at runtime right now? Do I need to like eval this? Yeah, we need to like sometimes figure out the timing of this thing. Yeah, there you go. It actually worked. This actually worked. Because when I implement type as trait right now, I don't do it immediately. I don't do it at compile time by default. I do it actually at runtime. Which means that I can have conditional implementations. If t like something something, then I implement it differently, I suppose. Um I don't like how this looks, but wait, why am I doing it at runtime, actually? Why am I not doing it immediately? Is there a reason for me to have the implementation added at runtime and not at compile time? I mean, potentially, right? Potentially. Can you construct an implementation race condition? Yeah, I guess. Right now I can't do anything. I can do if RNG, I guess, right? I can do something like this. So we are deriving for the boolean, right? We can say that if random gen, I can only generate the range right now, right? So we generate the range from 0 to 1, I guess. And if this is equal to 0, then we do this. And I guess otherwise we just return ha ha ha. Why did I write a singular equal thing there? I'm not sure. I should make my language server faster. I need to make sure that this knows the type. There we go. Ha ha ha. Ha ha ha. And then true. Rewrite it in Rust. That's not the no. It's slow not because it's not written in Rust. It's slow because there is no incremental. Like I recompile everything from scratch every time a single character changes in my file right now. And I'm waiting for the compilation for type inference for everything to do for the entire workspace. So for all of the Kast code that I have in my workspace right now, which is, I mean, it's not a lot, right? But I guess it is more than 2,000 lines of Kast code already. Can you make it require deterministic context or something so your linter can trust your code? So Comfort will agree to switch to Kast? Yeah, I mean, yeah, that's the idea. I just don't have it yet. I don't even have the inference for the context yet, but yeah, that's the idea. So at compile time, you want to make sure that certain things are actually not happening, right? Maybe you can ensure that the your random library is not reading your like secret files or something. So you don't want to give it access to the file system, or you don't want it to have access to the internet or like whatever. So yeah. That's exactly how I plan to do it with the contexts, compile time contexts. But for now, we just allow. I remember instant still meant something. 2,000 lines of Rust compiles instantly. I mean, yeah. I could also make it just faster, not like not by making it incremental, but by just making it faster, I suppose, somewhere. But that's more difficult. Like you know, there's a lot of boxing happening, a lot of pointer chasing in the thing, right? Instantly, as fast as instant noodles are made. So 3 minutes Kast is faster than instant, yeah. All right, we don't do this. We do that instead. Rust is blazingly fast and memory safe. Kast is. I don't know. Kast is. Kast is. I don't know. I don't know. We need to like you don't just like come up with a phrase while making a language, right? You come up with the catchphrase once the language is actually being used, right? Once it becomes something like better than something in a specific niche or whatever. Do you do some structure pool allocation stuff? Well, I mean, to make it faster? I mean, yeah, I guess. I mean, at the very least, I get one of the ways to make it more cache friendly or whatever. Like when you have your ASD, you just store all of the tree nodes in a single like array, right? And when you refer to it, you just refer by index there or something, right? Isn't that how you do it usually? But that's not what I do, right? So my actual memory representing the ASD is all over the place. I mean, yeah, basically just use the arena allocator everywhere, I guess. From what I see, it's kind of like an omni language. Yes, it is supposed to be the omni language for everything, but maybe we will use it for something specifically and we will realize that it's like better than other languages in some specific thing, right? But we need to get there first. It is supposed to be the omni language though. Like literally used for everything. You know? It's compiled, interpreted, embedded scripting as a shader. I want to transpile this to shaders too. Right? We use it as the configuration language. Right? Have the cast object notation. So this is just me defining the what the LSP should work with, and this is just regular cast code. Defining my workspace, basically. I don't know. John transpile emits per v. Yeah. Yeah. No, I'm going to transpile to GLSL because I will be using GLSL. SPIR-V is not usable everywhere yet. Can you like even supply SPIR-V to the web GPU like in the browser? Does it eat the SPIR-V? There's SPIR-V here. I don't see any SPIR-Vs. I do see GLSL though. So yeah. Because then it would be a double indirection, right? We compile to SPIR-V and then generate GLSL from it. For configuring the leaking language server, yeah. All right, let's get the interesting part. So let's say that the reference, right? So the reference reference. We have a mutable and referenced. So in this case, I want to print the reference plus If mutable, then the result plus equal mut, right? That's not like how we want to actually derive it, but I mean, that's not how we want to print, because this is, I'm trying to print the reference, right? So I want to print a reference. I probably want to order to reference it or something, right? That's how you implement it in Rust. But let's just say that we are just going to do this. So we're going to print the references with these things. So it's going to be a reference 20, for example. That's what we are going to see. So in this case, we want a self. Self is the reference. It's a reference to reference. So it's like I need to dereference the reference, and then I need to print it, right? So I can say referenced as to string self, and we say result plus equal, and then we return the result. I mean, or I can use this function and make this inferred, but this is that this type is the same as this type, supposedly. So let's say that I cannot derive the generics yet, but I can like derive a reference to boolean as to string. I guess I can do that. Making a generic ones. It would be nice. So in parentheses here. Yeah, this issue is also not solved yet, because reference to boolean can mean two things. It is either a type or a reference to the type. So now I should be able to print the reference to reference if this is implemented in the in that native function. Which it's not, right? This over here, if we have a reference. So if I have a reference, reference is mutable, referenced, mutable is mutable. What do we have inside there? It's just mut. Then we're going to construct variant called ref, and we have some associated data here. So this associated data and now I need to figure out the type to construct like this thing actually. Yeah. So construct variant then should basically be the function then that takes, so like how do I construct the data, right? I construct the data by saying like by having a function, like, so yeah, data is basically a function. If I know the type of the data, then I will construct the value, right? And this function is going to be optional, right? So here's we have data. Some data. Okay, so we say that data is data type. Data type. We just call this function with that. Let's data. Get this. So in these cases, the data should be yeah, I need like return here. Return our I guess with return could end like over here. So this should return value shape. Oh my god, I hate OCaml. Why don't you annotate everything? Why can it not just infer the things? I cannot even specify the type here. This is so annoying. Wait, can I specify the type here? Like, I cannot specify the higher order things here, or can I? Maybe like if I parenthesize here this? No. Is there actually a way to do this in OCaml? Let's just GPT. When pattern matching record in OCaml, can I type annotate a field as polymorphic function? Only in a very specific, slightly cursed way. So you can specify this inside of the type, but you cannot do this when you are doing this, because that is very annoying language. We want to annotate the record type, not the field. Yeah, I guess that makes sense. Return handle. Yeah, that's the reason why we have it inside of this thing. Value shape return handle, that's what we want. And now it knows the types. Even though OCaml could infer all of this. All right, so in this case, we have sum. We have a function which is the type, like data type, I guess, and we need to construct the data with this type. So what is the type here? Well, I mean, and this type should have two things. So I think similar to construct variant, we need to construct a tuple of this type. So I will construct a data type, and we will give it the list of fields with their values, right? So we want the mutable or whatever, mutable and referenced, right? Right, so mutable is mut. So mutability can be inferred, by the way. Can I say is mutable await inferred, I guess. Await inferred or inference await inferred. Our shape is going to be just false, I suppose. Okay. So we just do await inferred here. And this should be a boolean, right? So we say value boolean this value inferred. And then the second field is going to be referenced. And this is a type. And this is a type which is referenced. And that's all, right? That's all I need to do for this one. So the construct tuple is going to be taking the type tuple and the fields, which is a list of string and value list. I kind of want this to also have the function, I guess, from type into value. And this is what's going to give us the value, right? So like, because because we potentially want to use this type to construct the value of the field, just like I did for the data type here. But I will ignore the type in this case. Value data has type value, but expression was type of value option. Some data, none. All right, so this here, construct tuple fields. This means that all of the fields are actually named, which means that this should be like named fields, and we potentially should have unnamed fields. And this is just going to be the type into value list, right? So we have no unnamed fields. Construct tuple. So we want to well, I don't need to find anything here, or do I? Well, I mean, yeah, we need to like find all of the things, right? This list and the named fields, this should be the same. Actually, wait, hold on. Doesn't this mean that I need to have just a tuple of type into values? That's what I need, right? Yeah. We just need a type into value tuple. That's all. So over here, we'll just say tuple make. All right. So since this is a tuple and that is a tuple, now we need to say type tuple, and we say tuple zip order A, I guess. Type tuple and tuple. Let zipped is this. So zipping can fail, so we are going to try, and with invalid argument. In this case, I will actually report the error. And I will return the error shape, right? So now we have the zipped thing, and we just say zipped tuple map, right? So this is a type tuple, so where we'll have a type tuple field, the type field. Type field is type tuple field, and we want to return the value tuple field, right? Yeah, it will do value tuple as this. We also need the type here, I suppose. So yeah, we have a type tuple field, and I also have the value so this is like the value constructor, yeah. So this is title field times type into value. Right, so I'm going to call the value using the expected type, so type of the field, we know this here. Now we have the actual value. The value tuple field must have a place, span, and type field. What is the span used for? I don't know. Place, span, and type field. So the only question is what's the place? And place is just going to place in it with inherit mutability with the value inside, right? Okay, I think that's it. And this is relatively simple now, right? It did not work. Interpreter error, tuple zip unnamed. Oh, wait, what? Oh, that's not a very good message, but what it means is that this tuple zipping failed. Unnamed means that I have a different different lengths of the thing, of the arrays of the unnamed fields. Oh, I know why. I know why. Wait, do I know why? Yeah, I do know why. It's like the same change when I made when I made my variant. It's because the variant contains technically a tuple with a single unnamed thing now. Let's see, type variant. Variant, type variant data. So yeah, this one over here. This data should not be type args. I think. After all. And the data should just be a single value. So I made the function arguments. So functions technically like have properly multiple arguments. They're still backed by tuples now, but functions are no longer semantically functions of a single argument. So I did the same for the variance, but for the variance, I still want the variant data to be a single thing. I'm pretty sure. So let's revert that stuff. Oh, this is going to break everything. Is it? Or is it not? Let's actually see. It's probably not that bad. Doesn't change a thing. Wait, maybe I did not do it properly yet, because in the core syntax we have variant impl. Is that the thing? Yeah, over here we have tuple impl, where I should not have a tuple impl. In these three things, right? We just say compile expression. I mean, yeah, that's all. I think that would do. Okay, it works. Look at this. So I have derived. How do we print the reference to a boolean now, right? So we have a reference to false, right? And it is printed as reference to false. Okay, nice. All right. I don't think I will be doing the generic implementations yet. So we want to derive generically, right? For everything. How do we want this to be looking like in the future? Like derive generic t type reference t as toString, right? So that we do the generic derive here, like that. Maybe I should think about just the generic, like, because this is syntax sugar, of course, right? The generic implementations is what we want to figure out the syntax for. So Rust just has impl t, like toString for reference to t, right? That's what we want. This is like Rust, right? And in Kast, we want to say basically impl t then too, right? Reference t. So in this case, this must be a type reference t as toString, I suppose. Yeah, that makes sense. T in this case must implement toString also. So we should like also be able to say where t is toString. So I don't have these where clauses for my generics yet. But I think the where clause should go next to the argument somehow. Like, I feel like with t as toString or something is what I would want this. Maybe. I'm not sure yet. Hello, Davros. Everybody uses SperV except web society. If we had SperV on the web, start flying car meme, yeah. Society if we didn't have to squeeze everything into the web. I mean, is it like, I mean, yeah. I don't know. Everyone uses SperV except web, but isn't it like everyone uses web except for those who use SperV? Like, because I don't know. Is there more stuff that is web compared to the stuff that is not web? right? Like my VS Code here, that's just the browser, right? Basically. Not sure about the other things. Oh, my Neo Vim, I guess not is not a browser. Yeah, the generic stuff. I'm not going to work on this today. Let's just add more things. But as a proof of concept, I think this is already working. Right? It's just I just need to do more. So let's commit something at least. Right? Deriving proof of concept, I guess. And then we just keep on adding the things. One of the interesting thing is the recursive ones, right? Can we have a recursive type? That would be nice if I could do that, right? Well, when we just inspect the type info. Yeah, this is the interesting part, right? If I have the type, which is a tuple, or a variant. So let's say that I want to implement, I want to derive it. I want to derive a foo s2 string, right? Where we have our own type foo, right? Which has I don't know, int and boolean as fields, right? And then I want to dbj print to string you know, int is 1 2 3, boolean is true. Is my LSB not working? I think it's because the deriving works at compile time, so this actually fails to compile, right? Well, it makes sense. So we just have a to-do over here, or have a type tuple. So let's implement this one. Right, and what do we even want to have here? That's a good question, because the tuple is the thing that has fields, which means that I have lists. So how do I construct the list? Because I don't have lists in the language yet. That's the weird part here, I suppose. Let's comment this. So this doesn't work at runtime, but it's supposed to work at compile time now, right? Why can I still not hover anything? My language server. Let's restart maybe. Oh, there you go. This works. Hello, Pigorli.
Hello, Pigorli.
Boxed wine. That's juice. Can I not do this because I have because that's a tuple? Because I don't have lists. So the tuple, what should this have, right? Type info, tuple, right? What is type info tuple supposed to be? So we have the single thing tuple for literally everything. So we have unnamed. It's supposed to be a list of types, and we have named, which is supposed to be a map, I guess, from string into a type. So that's what a tuple is. Okay, it's not only about the lists, I guess. Unless I give you the type information in the form of unless the type information is given in the form of a, like, this named, this would be like also a list of like string type tuple instead of a map, because how would I construct a map from inside of the interpreter if the map is defined in the language? It's not impossible, it's just a little weird. I think we should instead go for the simple approach. And for the simple approach, so right now my lists are implemented as strips under the hood. So how about we say singly linked lists, because that's going to be like the simple one, you know? Can I say that single list is a thing which has type T, which is either, you know, so we do it like in functional languages, right? Either nil or cons of you know, value is T and tail is TT. I don't do of. I'm not writing a camel here. So in this case, the single linked list would be able to be constructed relatively easily without us adding the native list yet. But in this case, right, so we have a tuple, a named, and we need to figure out what is it that we have there. So we want to construct a string here though, right? So let's say this result is, we're going to start with an opening curly bracket, I guess, right? Close the bracket later. And then here we're just going to say that add field with name and value, right? So that's just going to be something like match name with none. Now let's do this. If name is some name, then we will do something, right? We will say result plus equal dot result plus equal. So name in this case is a string, so we just do name. And then we say result plus equal sign. Then we also say first is true. If not first, then result plus equal comma. Result plus equal no, first is false. Okay. Equal name. And over here we just say toString value. So what we need to do here is we need to iterate over these things. And this is the interesting part, right? So I need to derive with the repetition. So how do we do this? How do we do this? We will need to say let's just say add fields here, right? Add fields. So unless I add some way to like have the unwrapped repetitions, we would need to construct the AST like this, add fields. So we are going to start with the empty AST, right? So we don't actually print anything there. And then we would need to go for index. and type, I guess, in unnamed as list. We will need to iterate over this thing, I suppose. And inside of here, and we also will need to std iter enumerate. So we say that add fields is add fields, and then I want to call the function add with name being none and value being self. This is also interesting, right? So how do I get the field indexed I here, right? The field indexed I. Well, I mean, I cannot just do self dot I because I is not the AST, right? The I is an integer here, so this doesn't really work. Let's implement the iteration first, I suppose. So iter t list is tt std iterable t, right? So match list with wait, what? I feel like this can be implemented in a better way. How did I do it for trips actually? I mean, that's how I did it. But in case how I this list, it can be like really deep. And we don't have the tail call optimization, so this is not very good. But yeah. But basically what it means is that I go for X in iterate tail, and we just call fx. But it's probably, yeah, we just do iterate tail, iterate f. It's the same stuff, kind of. Alright, so right now we're just going to have a to do in the interpreter. Right? Or no? Wait, no, I actually have the inference failure in the for loop. Over here. iterate, enumerate, iterable, and it gives me iterable. Oh, well done. It's because, yeah, well, I don't use the round brackets for tuples anymore, and my error message is just bad here. No implementation of derive foo. Yeah, so we actually want to derive foo as to string here, but if I do that, then we have now the to-do list over here. So we in the tuple. So if I have a tuple, then I want to construct variant called tuple, and we have some data. And I will want to construct a tuple there. But the fields of this tuple are going to be just unnamed and named, which are lists. Unnamed and named. Okay. So this is the list type. So what I have to do over here is I need to construct a list using this list type, and the values are going to be something. So this is a list of types, right? That's all that we want. So here's the tuple, type tuple, type tuple, unnamed, array to list, map function, field, type tuple field, and this should return field type. And over here, I will also want to construct a list, but differently. Let's just say that for now, let's try just do the anonymous one. Nah, let's write this immediately. So we have type tuple. So I want the named ones. Named order rev. Named string map to list map name and field. This needs to have the list type. construct list. Yes, like if this is a list type, I need to know the element type. In this case, the element type is supposed to be just the type. So I don't really care about it. But in this case, the element type is a tuple. So I will need over here to also construct a tuple using the element type. And I will have two unnamed things here. So the first thing is going to be a string name. And the second thing is going to be the type. This also probably shouldn't be just the type, it should be the type. Okay. Let's see if I can implement construct list here. So construct list. So this is the list type. And it should have the function like which is a function from the element type. So we give it the element type and it returns the list of values. And this should return the value, right? There you go. How do we write this? First of all, the list type must be the variant type, right? So let's say that list type must be a tuple. Because we will basically, yeah, we need to first figure out the type. There's a tuple type, right? Then list type. Option unwrap. Also, let's not forget about that. We want list type. So we have a name. The name must not be optional. So we will unwrap this. List name. And list name, we're going to say that. So element type is match list name. So this must be the instantiation. If it is anything else, then we're just going to fail. Impossible. The instantiation here has generic and arg. We are going to ignore the generic. We are going to only have the arg. And the arg is the element type. Because the concrete list type that we want, right? the concrete list type that we want is this generic instantiated with the type of the element. That's what we are doing. So now that I have the element type, I'm going to say that values is f called with element type. And now we want to construct this recursively, right? Let rec construct values is. So we're going to construct function. So if it's an empty list, then we want to construct a variant of the list type. It's not a tuple, it's a variant, by the way. It's this thing, list of list type. We need to construct a variant called nil, right? And the data is none. We're going to construct using f element type here, right? Element type has type value. Oh yeah. So this must be a value, right? So say argument value expect type option unwrap. I'm writing too many unwraps lately. Okay, so it's this, right? Oh, but if it is like head tail, right? In this case, we want to construct variant of the list type called cons. Let's see, how did I do this here? Did I name my things? Yeah, I did name my things value and tail. Cons. So the data should be construct tuple of this, like this is data type. Data type must be a tuple. Should be some function. Data type must be a tuple. So we're constructing a tuple data type. This has two named things. First of them is value. And this one has value. And the second one has the tail. And the value of the tail is just construct the tail. This must be option unwrap. Expression type value tuple expression was expression of type blah, 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 blah. Of course. Okay, is this going to work now? Or did I not write something in my code? Or did I... Unwrapped none, actually. Unwrapped none over here, instantiation. Because I instantiated something with something that's not a type. Okay. when I was deriving foo as toString. Because it's a tuple. I was trying to construct a list. List type. Unnamed and named. Those are both list types, right? Unnamed and named. Those are both lists. This is type. And this is type. Both of these things are types. Alright, let's print what they are. Unwrapped none. Boom, 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 boom. We just do unwrap or else we fail. A list instantiated not with type but with value print arg. Let's see what it actually is. Oh, but with type. Oh, right. Right. Because the instantiation, okay. It's a little bit weird because instantiation, this is like args. This is args. Not a single argument, but multiple arguments. Technically. Single arg. That's in the interpreter common, which means that I probably can do it here if it's in the natives, right? Instantiation. Let arg is single arg. No, OCaml language server is dead, it seems. Okay, look at this. It worked. First try, easy. Why is my OCaml, like, OCaml language server is now... I hear my my fans, my CPU fans like working full speed or something. My OCaml LSB is using the full core. I think the OCaml language server is in the infinite loop right now. Because, like, what else would it be doing? It's literally just stuck. Alright. Well, let's kill this one. Is it going to restart itself? Or do I need to tell it to restart itself? Oh, there we go. Yeah, I don't know. Alright. Not my language server is bad, but the OCaml ones is also bad. Okay, so it seems like I have constructed these things, and now I just need to implement this thing fully, right? So, yeah. Because we don't have any unnamed fields, so this one was actually not tested. Right? I should try, though. What if I try over here to have the unnamed field, you know? Unnamed field of, unnamed field of type... like... unnamed field of type. I don't know. I mean, let's have a reference to a boolean here, sure, because we already tried that, right? So we just have a reference to false as the first unnamed field in this struct. That should work. But it didn't, because it could not find add in scope. So this actually makes sense. This is the same issue. So by the way, I mean, this is kind of expected, right? So because of the macro hygiene, I'm constructing two ASTs here, over here, and then over here. So this symbol is defined over here, but we're using it over here, but it's not available in our lexical scope. It kind of makes sense. It's just something that you're not used to when you are used to writing the macros in Rust, I guess. But it kind of makes sense. I just need to introduce this symbol first before constructing both of those by doing this, and then saying add here, and then saying let add here. Hello, Valley. You think an LSP4 language which has much recursion as a camel would be more careful with avoiding infinite loops? Yeah. Okay, so now derive foo. This doesn't have fields, of course, because we are given the reference, so I need to first dereference self and then get the field. Now it's going to complain that the field I is not there, which makes sense, right? Because we are trying to get the field number I. But if I say $I here, then this is not going to work, because we want to have the AST, but it is not AST. Exception, child must be AST. Child must be AST, right? But it's not AST. Let's say what it is. AST. Got this value print child. Right, so we were expecting AST, but we got 0 instead, right? 0 is the thing. So we need a way to convert the integer into the AST representing the field, right? Into the AST representing that number, I suppose, right? So in Rust, you would go into the and you would use the sin one to construct the index. That's what we want. The index of a named tuple struct field. That's what we want. I'm trying to create the index from an integer and then inject that into the code that I'm generating, right? But I mean, we're just creating the AST, and for me, those ASTs are literally just number literals. So I just need to convert the thing into the literal, which means that we need to have another native function which takes an integer and returns the AST. Right? I don't think I can implement that in another way. Right? So over here, I will just say that I is... So we need to have an AST, but in this case, I that we have here that one is an integer. And we need to convert one to the other. So I guess it should be like... So we need to have... So this is a reflection. This is me getting the information based on the types. But we will have another thing in the standard library. The way to construct the AST. Or I mean, the syntax nodes. So something similar to the syn crate. Do I call it syn too? Let's call it syn. I don't know. I mean, we can call it syntax, right? STD syntax. Why do we need to abbreviate things? Syntax. Literal. Int. Let's just say literal number literal, right? Which takes the integer and returns AST. Right, and this would just be a native syntax number literal. Oh, syntax is actually... Is syntax actually the keyword for me? Because I have it in the syntax for implementing syntax, I suppose. Let's do this for now. I think it should not be the thing at all. Also over here. No, I can do equal if I do the colon here, I suppose. So this is going to be syntax number literal I. I also, like, as you can see over here in the Rust crate, we need to give it the span, because that's how we get the error messages back, based on the spans. But what would I have as a span for this? I need to... let's just forget about it, I guess, for now. And we just want to implement this thing. So module syntax. So we have a single native function called syntax number literal. So we have a single argument. This one must be an integer. And so I need to create the AST. I need to create the AST. In this case, we need to construct a token, which is I do have a span, but this span is the oh, this is the common span. Oh. I think this can be my span. The span, the caller of this function. For now. Alright, shape. So we need a simple token comments before. We don't do that, right? And we need to have span. Alright, simple. Comments before empty. Token is another thing, which has shape, which is a number. And it has span. Data. Here must be span. Has TST in it. I just need to initialize this thing. So number now. Number has just a raw. So token. So just convert these to string and that's all. Int32 is not type. When I'm compiling this thing. Yeah, that's right. Because if I just say the type, then I don't do this. Okay, hold on a second. False is there. False is there. But why did it print? Hold on. If first, then result plus equal space else this result is false. Okay, this is better, right? But why is it not printing me the reference? Because isn't this a reference to false? So I'm supposed to print a reference to... Oh, wait. Am I just printing to string? Yeah, because I need to give it the reference to this to the thing. Reference to the field, because that's what I'm printing. Right? There we go. Reference to false. Nice, nice. We're almost there. Almost there. So now we need to go over all of the named fields too, right? So the named fields are just going to be name and type. Right? And I don't need to enumerate here anymore because these are named. So in this case, I need to convert. So in this case, we just need the not the number literal. We need to have this name, which is a string, and convert it into the identifier, right? So this should be syntax identifier ident. name. So this is going to be a function which makes an identifier given the string. And we get the field with this name here. And this is going to be a sum. But in this case, name must be a string. So let's rename this to identifier. And this to identifier. So similar to the number literal, we need the identifier, but this one takes a string and returns AST, right? So we need a native function, syntax ident. This is going to take a string name. So we need to create a token name, which is the identifier. Raw name. This is going to be identifier token. That's all. Is that going to work? It didn't. So it says that the type is wrong. Because boolean is not integer. Wait, boolean is not integer. Well, first of all, I have not implemented the thing for the integer. Right? Oh, wait, I know why. Because this add function, it's a single function, so the type of value here is not generic. So, because, yeah, this must be generic t, and the type of the value must be t. Or, I mean, it should be like reference to t, I guess. Should this even be in the generated code, or should I just inline this code in the thing? That's another question. No implementation of int32. Yeah, I think this is it. I just need to implement int32 as toString. Number literal inferred as string. 0. Yes, because this is toString. It's not that. So in order to convert this to string, well, I mean, the way to convert the integer to string is by using the native function, I suppose. We can write our own custom function that converts an integer to string, I guess, if we really wanted to. That's doable at this point. I mean, let's do it, I guess, maybe. Let mut x result is this, return result. I just say that x is self, and then into Well, I mean, I'm not supposed to derive it, right? I'm supposed to just implement it. Yeah, that would make more sense, because I don't derive for these native types. I just implement directly. But whatever. So I just say that, I guess, while x is not 0, right? I say x divide equal 10. Result. I don't have. I guess it's not really doable because I cannot convert a character into a string, maybe? Right? Can I create a string with a single character? Well, I mean, I have a chart to. I mean, I have these two string trait, which is the trait that is supposed to be derivable, by the way. And I already have the implementations for all the things. Yes, for some of the things at least, not for all of them. Why do I even declare my own toString? Because we already have it. I mean, in this case, we take a reference. And that toString was not taking a reference. So, yeah, and if I change that, then, yeah. I mean, let's just do this. Using std string toString C, I guess, where C is char from code, char code of 0 plus the digit, where digit is x%10. We also need to say that if x is less than 0, then we need to say result plus equal minus sign, and x is negative x. Wrong way around? Which one is wrong? Well, I mean, it's in the opposite direction, right? It's the inverse string right now. So I need to also inverse the string. Yeah. How do you inverse a string? I think I already did this. But how did I do this? Wait, can you do it without, like, accumulating and then reversing? Can you do it? Yeah, how do you do this? I never implemented the converting of the integer to a string manually. I mean, I did, but with reversing. Can you do it without reversing? Like, let's say that we want to print a big integer, right? With like 1 billion characters. That's not how we would write it, right? I mean, or is it? You could shift the characters. I mean, yeah, we can just say that instead of result plus equal, we say result is equal to string C plus result, I guess, right? Because we... Wait, what? I need to add the new the digit. I mean, yeah, I am adding the digits to the left side. That's right. Yeah. No, that's right. But yeah, it's not like. Yeah, this is doing a lot of allocation though. Unnecessary. And I mean, we don't care about this right now anyway. You could also recalculate the length of the string to avoid moving everything every time you add a digit. Yeah, I guess you calculate it once. Yeah, that makes sense too. Also, I mean, ideally we don't have a toString trait. We instead have something similar to the Rust's to the Rust display trait, I guess, where we don't construct a string. Actually, we just write something to the writer, to the formatter or whatever, right? So we don't even allocate the string. We just like need to like do things. Not struct display. Display. This thing. Implement display. Let's see how they implement it in Rust. Optimize for size. Optimize for size. Lossless conversion with as is asserted at the top of this macro. Concat. Max dec n. So you actually, they actually create a buffer before writing, right? Yeah, you create a buffer and then you like, I don't know. Pad integral underscore FMT, whatever. Okay. I don't think having separate debug and display traits is a good idea. Yeah, I think you are right. But I mean, at the same time, I think that having a if you want to specify a pretty printing for a type, you should just use a normal function. So it should be general. Yeah, I think debug and display are too common. But what I want actually is a different trait than debug, which would allow me to do more things than just printing. Because in order to debug a thing, I might want to show the thing that I'm debug printing in an interactive interface. Like over here in JavaScript, right? You can do like console log, document, right? So I want to debug print document here, and I get this thing where I can which I can interact with, right? That's what I want to have instead of just the debug trait. I don't think that this and the display. I mean, maybe they could be merged, but this would be what? How is this even implemented? I don't know. JavaScript inspect API, I think it's called, but I'm not sure because I never looked into how they how like, can you even like have a custom thing in the console, or is this hard coded? Because I want it to be not hard coded, right? This also means that when I'm debug printing like things, then we would also see them like highlighted. That's something that Rust does not give you when you debug print your object, right? So syntax highlighting, interactivity. I want to support that when debugging. I feel like that should just be a recursive function that has a lot of cases and maybe use a display trait internally. I don't know. I know I didn't really think about it much, but I'm just saying that I want to have the ability to do like that stuff. But yeah, look at this. I have successfully derived toString for my custom thing, and we see it on the screen now, right? We have a field boolean, which is true, field int32, which is 1, 2, 3. This is nice. How complicated is this? I feel like, so the most complicated thing to write this derived macro is the macro hygiene, which means that you need to like introduce the symbol in case you are constructing multiple ESTs in multiple places. This is a little bit not intuitive, maybe. Odin has W format strings that print out valid Odin code for constructing the type. If you did that, you could just parse it as AST and display it any way you want. Have a trait that dumps the AST for constructing a value to count out the middleman. Well, yeah, it's just not always the AST. I'm like, sometimes I feel like like it's not just AST. You know what I mean? I don't know if I can give you an example. And I mean, well, it's not always the AST, right? If I console log, this gives me the function log. Or is this still considered AST? I mean, I guess. Like, I can imagine debug printing, for example, an image, or literally an image, right? Because let's say that I'm making a game and I want to debug the fact that the image is loaded properly, right? Like, why can I not just insert an image here? Right? So it's not an AST, but it is we could have some form of a tree, right? Which allows all of the things, which is basically almost like HTML, I suppose. Maybe. I don't know. Is there any the higher level code could parse the AST and handle the image data specially? Well, I mean, yeah, you have like the specific logger. So you have different loggers, I guess, right? So for example, in the browser console, you actually have the interactivity, right? If you try to just log into a file, then you obviously don't have the interactivity. So like that's the different implementation. And we want to, of course, decouple the way we construct this thing to be displayed versus actually displaying, right? That's what you're saying. Yeah, I agree with that. So there should be some intermediate representation. I don't think it should be called AST though, but I mean, yeah. So there should be a trait which outputs something like high level, right? Like let's say that the display trait was implemented in Rust with the SERDI, right? So the SERDI in Rust it basically has its own intermediate representation, which you go through in order to then serialize into the specific format, like JSON or some other format. So it's similar to that. I think there's actually crates that just implement debug with SERDI. Fast derive debug with SERDI. Debug. Drop-in replacement for derive debug, this thing. Right? Drop-in replacement for derive debug that uses serialization under the hood to provide advanced control over output serialization. Because like when you print the thing, that's literally just serializing. The main thing I know about SERDI is the infamous compile time code size from all the monomorphization. Yeah. I know that I don't want to do monomorphization for debug builds for sure. So yeah, but derive macros, this is actually generating the code. So but we do have the reflection type info, right? So we could potentially, instead of generating the code, save the type information into the runtime and like do something there. That's what the there's a new nightly API in Rust. Type inspection, which is supposed to be like the same thing, I think. Is it actually called type info? No, I don't think so. For functionalist languages, you probably have to do some amount of polymorphization. Always for acceptable performance. Well, I mean, I want to be able to do monomorphization, but I want it to be not required because I know how monomorphization can have a very bad impact on the compilation times, right? because that's the reason I'm writing OCaml and not Rust right now. Runtime type information, yeah. So like I don't know if you've seen that. I was investigating it at some point. There is a method called existentialization, which is how Swift is compiling code instead of monomorphization. So Swift is a language that is pretty fast, right? But it is not doing monomorphization. So Swift protocols are just traits, right? And this generic argument to your generic function basically becomes a runtime argument, which has the runtime type information inside, specifying the layout of the structs and stuff. So it does it without boxing the types either. You're gonna have functions, style map, filter, reduce functions though. You probably want most of them to be inlined. Yeah. Yeah, there are certainly things to be inlined. For example, I think it's not even like the map filter reduce. The thing that I was thinking about inlining was literally math, because the a plus b is syntax sugar for for like a thing which is not very trivial. You know. Because I did not even introduce the traits for overloading the operators. So yeah, like those definitely will need to be inlined. I think I should move this to the standard library right now. std_lib, right? Let's do this. Const syntax is include syntax. No, syntax is a different one, right? This is a file that defines all of the syntax sugar, and I want the file that is like syn. Do I just call it syn then, and not syntax? Because that's different. So one syn and I want reflection. Syn. I mean, or we just, yeah, actually, I think this could work if I just made the syn is like, as like associated methods for the AST itself instead. That makes sense. How far do you plan on going with just the JavaScript backend? I think I can like self-host the language with the JavaScript backend. Like JavaScript should give me enough performance, I think. If I cannot optimize the JavaScript well enough for the language to be self-hosted, then I'm pretty sure that my C backend would also be pretty slow, right? I don't know. Or do you think I should try to do the native backend before self-hosting? Or like work on those things in parallel? And the singly linked lists, I guess, can also go there. So do std reflection type info, single linked list. Field. Derivable and derived syntax. Let's keep it here for now. You don't like self-hosted languages, you like the idea that building a language from source is kept simple. Well, I mean, it is going to be simple, just run a single command, right? Well, I mean, right now to build, I also have, I need to invoke TypeScript compiler right now, and OCaml compiler to compile this. But it's all done automatically, so, like, I don't know. Like, what's the problem with self-hosting? Would you, like... Yeah, I have a lot of room to optimize for sure. I don't need the native... Well, I think the only reason to go for the native backend is just to, like, try it. Right? Because there are certain things, like... I rely too much on the runtime right now, right? On the garbage collector, like capturing the variables through the closures, right? Just like trying to generate C is fun. Because I have not done a lot of things. You just don't like how hard it is to get a clean cutoff. And I've given a chain of versions around just in case. Yeah. Well, I mean, you can, but you can just keep around the, well, you keep around either the binary or the transpiled version, right? And isn't it easier to make a language that's transpilable because you keep around the previous transpiled version, which is supposed to be like multi-platform, right? So yeah, if a language is just only the compiler and only the native one, then you need to keep around the native binary for all of the different platforms, which does make it a lot harder. But with a transpiled one, I think that's actually like very easy, especially if you transpile to C, because you always have the C compiler around you, and you can always just compile that stuff, right? Do you intend to implement transpilation from OCaml? Right now, I transpile from OCaml. I don't know. Maybe actually, well, that's going to be difficult, right? Yeah, maybe. So that we don't do the job twice. Actually, the goal would be to self-host the language first, right? Because the transpiler right now is in OCaml, and then write the transpiler of the self-hosted language into C, right? And we literally just drop the JavaScript transpiler then. So I don't even re-implement the JavaScript backend, because we can just transpile to C and then compile C to WebAssembly and do the JavaScript that way. Do the web that way. Maybe. So yeah, I think maybe that's the plan. If we don't hit the performance issues in the JavaScript, but we can optimize a lot, of course. Can find syntax in scope. So yeah, this should be... yeah, I think we just do AST dot number literal. There you go. That's what we want. So instead of saying synks, let's just say over here, implement AST as module as this thing. Right? So this is going to be just AST. What I call AST is just the syntax tree. It's not, I mean, whatever. There's so many lambdas in JavaScript. It's like the reverse of the old asm.js lol. I don't know if you have seen, I have changed my transpiler. I don't have a lot of immediately invoked lambdas anymore. Right now my issue is that everything is async. Code target compiled. Here is what my current JavaScript looks like. It's actually pretty flat now, right? Compared to before. Like I literally only have a function where I actually have a function in Kast code. Or generics. Generics are also like functions. But the problem is that everything is async, so I pay a lot of the cost of the micro task. So, but in order to get rid of the await and everything being async, I need to infer the fact that something is async or not. So that is also going to be done at some point soon. My issue is that everything is async. That's just normal JavaScript API problems now. Well, so like adding two numbers together is done. So a plus b is a syntax sugar for std op add ab, right? So an std op add is a function which like transpiles to JavaScript, right? But because this is a function, this function is transpiled to the async function. This generic also is another function. So this is like a function returning a function, and both of those functions are async. So we have like two extra microtask like steps compared to what we need, right? As a simple example. I think async is like okay, mostly. But like you just need to not do async if you don't need it, I guess. So in OCaml everything can be async though, and you don't need to figure it out. It's just a different runtime there, I guess. In Golang everything is async and you don't need to think about it much either. And you like there is not a big runtime cost, right? Because like you only like I don't know. It's just like the implementation details basically of JavaScript versus like other runtimes, I suppose. Okay, there we go. So this is the simple example. Let's get rid of this. Let's keep derivable here. Let's have this syntax here. ToString. It's like a different ToString, but sure. Everything is async would mean there's a chance to be interrupted at every point. I think either camel or Go is like that. Well, they are, though, right? But they are. The it's just that, like, so, like, when do you need to interrupt the current, like, task, or whatever you call it, the current coroutine, current go routine, only at specific points, right? So what is this point? There are explicit points where you are doing this in OCaml, and there are explicit points where you are doing this in Go. But in JavaScript, basically, when you're marking your function as async, that is automatically adding the yield point, I guess, which is unnecessary, which is not added in OCaml. You're not generating the code to check for interruption. Your interruption is like there is no such thing as interruption. There is yielding, right? Because you basically just have a native way to pause the execution of the current micro task, or like whatever you call it, right? The Go routine. You can yield to the executor, which is going to pause your current execution, and you can resume to it later. So in JavaScript, the way you do it, you create a promise, right? So promise, when you construct it, that's like your continuation, what is going to be like after that, you know? But so like you always construct a promise when you have an async function, but you actually don't in OCaml. As far as I understand, making an add an async function means it gets added to the queue of microtasks. Yeah, it's just like there is no queue of microtasks. You don't mark your functions as async, and they can still be async because it's just done differently, I guess. All right, I'm going to call it good enough for today. Good enough for today. All right. Reflection. Progress. I'm going to go rest. Do something else. There is still a lot of have to do things. But in general, the idea works. So we will implement the other things as we need them. I think the big ones now is just having the generic implementations. That's something that I don't have yet. That's the biggest one, and then the optimizations, the inlining of the functions. I want to do that, or I mean context inference. Yeah, I think those are the three things that I want to focus in some order. All right. See you guys next time. Thank you for watching. Bye.